Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate on the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Alright, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night, and VK7 Tango Whiskey on the desk tonight. And I'll take that off, given I'm the only one in the studio at this point in time. So we're going out on streaming, so if you're on the stream, please let us know. We're monitoring the chat, and we've got a few things tonight, a few different things tonight. Not yet. If I get Alan in the studio, I'm going to have to put my mask back on. So, the very first thing I thought we would take a bit of a look at is a funny, strange little film container. And it is an actual film container, 35mm film container, that has a funny looking LiPo battery in it, and also a little tri-band 23cm, 70cm, and 2 meter antenna on here, little stub antenna, and a SMA that pokes out the top of it. Now, what is this? This is a Byonics Microfox. So if I go here, this is the Byonics company. They produce a whole lot of fox hunting, so amateur radio direction finding, equipment and bits and pieces. And this is the MicroFox 15S. And if I open this little film container up, you'll notice that there is a little sealed up RF shielded box which has 140 to 150 megahertz on it. There's a little 2.5mm audio type socket there that you can plug in the USB programming cable that comes with it, and program it up. And then on the other side there is a microcontroller and a power connector. And then there is a PCB mount SMA on the end of it, which screws onto the lid of the film container. So that all fits in, and there is also they supply two of these 3.7 volt 650 milliamp hour batteries and these last, they say these last about 16 hours of transmission time. So and there's 2 of them, and you get a little USB charger as well for the batteries that's got the battery connector on the end. So, and get a very good little instruction manual, and the instruction manual takes you off for the 15S. It takes you off to a website, and the website gives you very similar to this Windows application, but very similar options that you can then program in, a whole lot of different options. This little chart here that has a whole lot of numbers on it is actually the it plays a little tune, and I'll play the tune in a minute. And you can change the tune by changing these numbers to a series of tones. You can put in the call sign, which I've put in VK7TW, and you'll hear that ident every so often. The speed of it, the tone of it, and then a little thing about when you connect up the USB, which COM port to connect to. So you can program this up, and it records and it stores that all in E2 ROM. So whenever you switch it on, it starts transmitting whatever you've programmed it with. I'll just switch this one on. You can see when we there's no on-off switch. When you plug in the battery, it magically starts transmitting the sequence. And I'll just plug in. I've got an ARDF antenna I'm going to show you in a minute. Now there's the little tune it plays. And it plays that over a few times. And then VK7TW Micro MIROF. Doesn't quite get the Fox, but it goes through that little sequence and continues to go through that sequence. You probably want to leave the antenna off. You can hear the attenuation by leaving the antenna off, or putting a dummy load or something onto it. Now, what I'm receiving it with is just a handheld, 2 meter handheld, which, if we come back to here, just a 2 meter, fairly old IC2 GOT handheld. Great receivers in these transmitters, in these handhelds. And it's plugged into, we made a little while ago some tape measure antennas. These are 2 meter tape measure antennas. It uses tape measure for the reflector, and then there's a director dipole here with two elements of the dipole, and a little matching stub, and then a director, one director, and it's all done with PVC pipe. So, and one of the reasons you use tape measure is when you're running through the bush, you can bang these and they fold back out again. And in fact, they use the interesting thing is they actually use tape measures antennas in quite a few of the satellites, because you can roll up the tape measure, and what they have is a little solenoid, and once they get into position, they trigger the solenoid, and out unrolls the tape measures, and you've got yourself an antenna. So so there you go. There's amateur radio direction finding. This is the receiving side, so you'll be running around looking for the strongest signal on the signal meter, listening to the tone and trying to find where the hidden transmitter is stored. So that's the MicroFox. So in future open days, we've actually got ourselves a little fox that we can hide off into the bush and do some amateur radio direction finding on the actual night. So anyway, that's and then I'll put a link in the description on the YouTube channel of the Byonics website and a few other things, so you can see the range of items that they actually sell, which is quite extensive, and it's not only 2 meters. They've got 80 meter ones. 80 meters and 2 meters are the two favoured frequencies for ARDF, and that's where all the competitions occur. And Brian VK7KAJ, who's a regular at Gipstech, has designed some very nice little ARDF receivers, auto receivers. They do auto attenuation and all sorts of stuff, because one of the things with ARDF is, as you get closer and closer to the transmitter, it becomes overwhelmed with signal and you lose the directivity. So what you actually want to be able to do is, as you get closer and closer to the Fox, you actually want it to continue to attenuate down, so you're down to a very, very small signal, so you can do that differentiation of where it sits. And Brian's receivers actually auto attenuate. As the signal gets stronger, it attenuates. As it gets stronger, it attenuates, and it just keeps backing it off. So very easy to use, Brian's little receivers. I've actually got one of Brian's receivers. I'll bring it in one day and we'll have a look at it. But anyway, that's the Byonics 15S, MicroFox 15S, that will be deployed in a future activity up here on the domain before it gets too cold and too wet, which we've had a bit of a reminder this week that it's getting a bit cold. But anyway, now we're streaming and looking at the chat channel, and we're also going out on RF. So I'll do a call on R2 at the end and find out whether we've got any watches out there, etc. So now what I'm going to do is just change over to that camera so that I can just set up. And if Alan's listening, Alan KAJ, if you can make your way to the studio. Okay, now let's zoom in here. What we're looking at here, let's try and zoom in here, a bit of focus. Oh, we can just see that. We can just see that. Okay. So, what we're looking at here, I'll zoom out a little bit here. What we're looking at here, that's a frequency counter. That's a frequency counter. So we've now got Alan in the studio. I'll get this side of the camera. You get that side of the camera.
But we need these now, do we?
Well, we do up until Friday. Then we can take them off.
Yeah, okay.
So we've gone a bit muffled in voice. That's understandable. But now, Alan, tell us what this is.
This is a Digiquartz pressure transducer made by Parascientific in the good old US of A.
Woohoo!
And I believe it's an absolute pressure transducer. We used to use them when I was working for the Antarctic division.
Okay.
In automatic weather stations.
Cool. Sorry, I'm going to put that there.
So we made automatic weather stations is a very, very long story.
Oh, cool.
Yeah, but I won't
No.
do the long version.
Let's sit up here and you can tell us the long version.
Oh no, it goes for days. I kid you not.
Welcome, Alan. This is VK7KAJ.
Yeah, I just
So-
make sure that's on silent.
Yeah. Unlike mine.
Yes, so, yes, weather stations. We used to make weather stations. Piece,
Word from our sponsor.
yeah, piece by piece for the glaciology section at the Antarctic division. They
Okay.
had some specific requirements for their weather stations, mainly this was for ice movements and glaciers. I think that later on they moved away from there and onto sea ice, depending
Okay.
on who was running the program at the time.
Okay.
But when I started there in 1988,
Okay.
after returning from south a few times, that was the first generation of weather station. That was made with entirely a 4000 series CMOS,
Ooh, okay.
mil-spec 4000
Yeah.
series CMOS.
But low power. That's
Oh, yeah.
very low power.
Yeah, low power comes into it a
Okay.
lot. A lot of the ICs we got, the special ones for various functions, and this is a long time ago, I've forgotten most of it, were ceramic packages,
Okay. Okay.
and as I said, mil-spec.
So that's the extended temperature range.
Yeah, the temperature range
stuff.
-55 to +150, I think, or something like that. Now, there's lots. Oh God, this could go on for hours. At one stage, we wanted some of these ICs. I forget what they were. They could have been A to Ds,
Okay.
or D to A's, or frequency to voltage, whatever.
The frequency to voltage.
Oh, there's another interesting story with those, but yeah.
Okay.
But the company we wanted them from said, we don't have any mil-spec ones.
Okay.
We've got some, but they don't meet the high temperature specs. Their low temperature specs are okay, thinking that we wanted the high temperature spec version. And we said, we'll have the lot. And we did. We bought, I don't know, 50 or so of
Okay.
these things,
Okay.
which is all they had. Yeah, the temperature, yeah. The weather stations we just used to put into the field.
Yep.
Nobody ever went back to service them. They had to work from the outset.
Okay. And they were solar powered, or
Sort of.
oh, okay.
At various times we had different ideas. Initially, the first batch we had, which was when I started there,
Yep.
they were solar powered. They had a 2.5 watt panel. No, was it 2.5 watt? Yeah, 2.5 watt panel on there to charge the 12 volt lead acid battery.
Okay.
Lead acid battery at cold temperatures is another very long topic. Sulfuric acid is a very interesting chemical.
Yeah.
Just for instance, at what temperature does sulfuric acid freeze at, oh no, not freeze. Yes, 100% sulfuric acid is solid at what temperature?
I don't know. I
It's
wouldn't have
about
thought.
room temperature. Just above.
Okay.
But if you have it at about, I think it's 36%.
Yep.
Oh God, I wish I could remember the numbers. Or an SG of about 1.35, which is what we put in our batteries. It's about -70 or about there. It goes a bit slushy,
Okay.
and it sort of does a curve like that
Oh, okay.
with SG and temperature and a few other oddities.
That's weird.
We used to make it so that our batteries, when they were at about 50%, had the lowest freezing point.
Okay.
And if they got full charge, they got warmer where they'd freeze,
Yep.
and if they got flatter, they'd get, yeah.
So there was a sweet spot.
Yeah, there's a sweet spot.
Yeah. Okay.
And of course the 1.36 is only at room temperature. When you drop the temperature, the specific gravity changes again, and it's a complicated subject. Anyway, that was something totally else. At various times we used lead acid batteries, NiCad batteries, lithium ion batteries, primary cells, never rechargeables.
Yeah. Okay.
The later ones used the lithium ion primary cells.
Okay.
They were a special case, very special. But the batteries we used, basically telecom batteries, the 4X, or FAURE, X batteries, which were clear plastic cases. We got the largest plastic case with the smallest capacity, so it gave us the most electrolyte, which meant that the SG wouldn't change as much between fully charged and...
Okay.
Yeah, okay, there was that.
Cool.
NiCads we used for a while because supposedly they're better at lower temperatures, but at about -40 or 50 they have an interesting effect when you charge them. From memory, NiCads are exothermic.
Right. Okay. So they give off heat.
They give off heat as they're charging, and once they're fully charged they suddenly become endothermic.
Oh.
So if you're charging them at around about -40, which is about the slush area for their electrolyte, depending on whether it's electrolyte A or B.
Okay.
And that's the difference between sodium hydroxide and potassium hydroxide and variations.
Okay.
If you start charging them, all of a sudden they drop their temperature again and go into the rather crystalline slush rather than the liquid slush.
And I assume that then the chemical reaction doesn't start happening, or slows down or something.
Yeah, all batteries get slower at low temperatures.
Yeah. Okay.
But and then later on we used the lithium ion ones. They were for special cases inland where we knew we would not be using solar power.
Okay.
And they were a total loss battery.
Yep.
But they were made of D cells.
Okay.
And there were 4 D cells in a stick, and there was about 20 ampere per cell, so that's a 20 ampere cell. And from memory there was total battery in a case about so by so stainless steel case. That was about 720 ampere of lithium cells. The actual current through each branch was next to nothing, which is another topic. And that would last at conservative rates for 10 years. In reality, they'd probably go for 15, 20 years to power these weather stations. The weather stations, the later ones, were only drawing around about 6 milliamp, or no, less, down around about 3 milliamp hour per something or other per day or something.
Wow. Okay.
Really, really low power, and most of that was in the transmitter.
Yeah. Okay.
On 401.65 megahertz up to a satellite, it had broadcast every 180 seconds, I think.
Okay.
Whether there was a satellite there or not, it would just transmit the data.
Yeah. Okay.
To the French system Argos.
Okay.
Argos system. Yeah.
Wow.
I've spent a lot of time on weather stations.
Definitely.
As I said, the first ones were all CMOS.
Yep.
The next ones we were using PICs.
Yep. Okay.
For each sensor, which would then talk to a bigger processor. And the last ones used a Motorola chip for every sensor and also for the motherboard.
Okay.
And so you could, and they were made so that you could put them together with gloves.
Yeah.
Got rid of screw threads. Everything was bayonet because screw threads get little bits of, sand or grit or ice, and you can't do anything.
Seize up, yes.
All the bolts were large so that you could do them with a gloved hand because these were put out in the field at -40, -50. The one with the lithium ion cells was to go at Dome Argos, I think it was at Dome C, which is just near Vostok.
Okay.
In Antarctica, not Vostok, in the other part of the world that we don't talk about at present.
No, don't mention the war.
Yeah. And Vostok has the reputation of having the coldest temperature of minus 89 point something.
Ooh, okay.
And we figured that because where we put our weather station at 100 metres higher, we would get adiabatic cooling and we might have hit the minus 90. But something came along and mucked that plan up, called global warming.
Okay.
So we never saw it. The first stations that they put out prior to me being there, I think some of them are still running.
Okay.
They're all buried,
Yeah.
so most of the sensors don't do anything. There were 3 wind sensors, wind direction sensor. There were 7 temperature sensors at various heights.
Okay.
Above ground was 1 metre, 1 metre, 2 metres, and 4 metres.
Yep. Okay.
Of course, above ground is relative because each year the snow would come up and eventually they'd get buried. And then we also had 4 underground, one at 100 millimetres.
Yep.
One at 1 metre, one at 3 metres, and one at 10 metres.
Whoa.
The one at 10 metres is interesting because the temperature there basically doesn't vary
Yep.
for
Okay.
the entire year. It's down deep enough.
Yep.
The 3 metre one, you still get
Variations.
yearly variation, except that it's months behind.
Yeah.
You get the time delay.
Okay.
You can still see that on the 10 metre one, but
Yep.
for all
The
intents
hysteresis of everything cooling down and warming up.
And of course you can tell which one's got buried because all of a sudden its daily variations
Okay.
suddenly disappear and the wind goes to 0 at that level also.
Okay. And pressure, obviously.
Oh yeah. Oh, hang on. Solar radiation,
Yeah. Okay.
which we used a Middleton pyranometer, which you had
Which
the other week.
Which we featured the other day.
week. We also had humidity at times,
Okay.
and the Polaroid, their Polaroid cameras, the colour ones that did the immediate, they had an ultrasonic ranging on them.
Yes.
We used those sensors were available for other people to use, and
Okay.
we used them for measuring snow accumulation. and
Okay.
the height. Yeah, so it was a lot of fun. And of course, the star of the show, the pressure sensor,
Correct.
which was, from memory, incredibly expensive. Was the single most expensive sensor on the entire device.
Okay. So you were saying last week, all up a weather station costs.
I think the last ones we did, we were working on about 60,000
Flipping it.
out the door.
Yeah. Okay. And a vast majority of it was that.
Well, yes, a fair amount of it was that.
Okay.
Yeah, we used those because of their excellent long-term stability, drift, and basically that they didn't vary all that much.
Now,
They didn't age.
tell us how they work, because this is fascinating.
Yes, I think you've read it and I haven't.
Oh, okay. Sorry.
It's a quartz resonator.
Correct.
And the pressure, air pressure is impressed onto the resonator, which alters its resonant frequency.
Well and truly.
Yes, and there's also a temperature variation in this, so to counteract that they have another resonator where they get the temperature from, and then they use that to correct the pressure.
And both the pressure and temperature are available to you.
I'm not sure if it is on that one, is it?
Well, according to this, it is.
I'm not sure if it's got the wire coming out, because it's only got one signal lead out.
Oh, okay. Maybe it's. How do I read this?
I think you need a few more. There were variants on it, and we might have even cut wires off the ones we didn't need.
215A. Yeah, if you knew these part numbers, you'd probably be able to tell.
Yeah.
But so pressure. The pressure signal is.
That's the best part, though.
Yeah.
The repeatability better than 0.005% of full scale. hysteresis better than 0.005% of full scale, and acceleration sensitivity, whatever that means.
And the pressure comes out with a 10% frequency change within the frequency band of 30 kilohertz to 42
kilohertz.
So if I scroll down a little bit here, and unfortunately it's oh, hang on.
Has it gone to sleep or something?
No, it hasn't gone to sleep. It's just very you can see there it's 37,888.
Now how long are the leads on it?
Well, they're not that long. It's over the side. It's over the...
37,887. Okay, if I lift that... Oh, no.
Yeah, pull it out. Just watch the clip leads.
Yeah, going up to there goes to 37,888. And if I go down to there, it's back to 37,887.
Yeah. And when I first...
888 again, but we used to play with it on the lab bench to see if we could tell the difference between the bench height and the and above. And yes, you could. And people opening and shutting doors.
Yeah.
Well,
air conditioning, of course.
On Monday night, when I first plugged it in, it was 37,900.
Yeah.
Then on Tuesday night, it was 37,858.
Yeah.
And then tonight, it's 37,888.
Yeah.
So the air pressure is certainly varying, and I've been watching the maps on the BOM site, the Bureau of Meteorology site, and it certainly there is quite a considerable high that's moving across us right at the moment.
Well, if you're into aviation at all, you'll know that pressure is there, and it will be something else anywhere else. You can't say the pressure here is the same as over there.
Correct.
It's always varying.
Correct.
Which, the temperature sensors are another one like that.
So
temperature is very hard to measure. Really hard.
It's like time.
No, it's probably worse.
Yeah, actually, you're probably right there. You are probably right.
The temperature sensors, we just ordered a bulk quantity of R23 or R123 or R53 thermistors, I forget which ones. They're glass tube with a resistive element in them.
Okay.
And then we select on test what they were at room temperature, and we used basically for each station 7 from roughly the same with the same value.
Okay.
And then we calibrated them.
Oh yes. Okay.
In a fridge with a platinum standard that was traceable back to CSIRO and back to NIST labs and whatever.
Yeah. Okay.
And it'd take us around about 2.5 days to calibrate these thermistors.
Yep.
And if you put two thermistors next to each other like this, they will read different, even when they're both calibrated to be the same.
Okay.
Because of air currents and the rest.
Yeah.
So what we ended up doing was we had a big block of aluminium, probably about 1 foot high and about 8 inches in diameter. We bored 7 holes or 8 holes in the centre of it and 1 in the middle. The standard went in the one in the middle. All the ones we were calibrating went in around the outside.
Okay.
And then we filled it all with silicon oil.
Okay.
Then we put it in our environmental test chamber, otherwise known as the fridge, which would go down to -80.
Okay.
With a really big fan
Okay.
in it. And we'd leave it there until the computer said the variation, they've all stopped varying, so we have stability, and then it would take a reading, and then it'd ramp up to another temperature, and wait until it did the same. And that whole process took around about 2.5 days to do. We'd set it off on a Friday, and it might be finished by Monday, depending on what happened over the weekend.
Cool.
And that was to calibrate these things to... The glacios wanted 20 millidegree accuracy.
Yeah, okay.
That's millidegrees Celsius.
Yeah, okay.
So we calibrated them to 10 millidegrees, which gave us 1 bit.
Yeah. Okay.
And in the data string that we used to transmit, I think there were something like 180 bits, and each sensor was assigned just enough bits to get the required accuracy.
Yep.
So some would have 4 bits, some
Yep.
would have 7 bits,
Okay.
and whatever. The pressure gauge, we had a problem with those at one stage because the transmitters we were using, which have rather tight frequency requirements, or phase requirements more to the point, we were buying those, and we were using signals out of those as standards to clock the output of those for frequency, and then doing frequency to whatever to get a number of bits.
Yep.
But unbeknownst to us, the makers of this thing changed one of the frequencies, and we started getting really weird results on the air pressure.
Okay.
And the air pressure only, it's the only thing we used it for. And that took us a long time to find out what had happened.
Yeah, okay.
Because it was random. We knew what the error was, we could correct for it,
Yep.
but we didn't know why it was happening.
Yeah,
and
okay.
they changed it from 440 Hertz to 400 Hertz or the other way, something like that. And all of a sudden the buffer would overflow, and we'd start getting negative pressures when the pressure was dropping when we knew it should have increased, and vice versa.
Yep.
Rather weird thing.
Okay.
Yeah, lots of fun.
Oh no, well and truly.
Spent lots of time on it
So-
over the years.
So
And as I said, some of them are still running, as far as I know.
Yeah. One of the things, because one of the things about this particular one is this is a 0 to 15 psi A, which is 0 to 0.1 megapascals, according to this.
Oh, yeah.
Megapascals?
Or more to the point, 0 to 15 psi.
Yeah.
In other words, 1 atmosphere.
Yeah. So that's what this particular one that you're looking at is capable of, and so yeah, I just absolutely fascinating, and I've now been looking up a whole lot of circuits and information around frequency to voltage converters.
Yeah.
And there's quite a few circuits out there, op-amp circuits and 555 circuits.
Yeah.
That was the other one that was an interesting little circuit, as well as dedicated ICs on a whole range from a whole range of IC companies, electronic companies. So yeah, absolutely fascinating.
Yes. And as I said, I can go on and on over this. I'm trying to... that might be it. I should... no, that's... Well, that's one of the old ones.
Okay, hang on. Cam 1.
Oh, that's not one of the old ones, that's one of the newer ones, made out of square... Oh, that'll probably change its format now. Oh, no.
No, it's okay.
Made out of square tube. And, yeah, the bottom's down this end. Each one of those, the closest arm's at 1 metre above ground level, the next one's at 2, and the top one's at 4.
Okay.
Each one of the arms, you can see there's little IP67 sockets.
Okay.
That's how they were connected,
Yep.
but they were also bolted on.
Okay.
So each arm had temperature.
Ooh.
Yeah, it does that.
Oh, no, hang on. Oh, there we go. No.
Yeah. And yeah. And the cable used to run up the middle. One of the problems with that, we used to use round tube earlier. With this, we discovered that they'd fill up with drift.
Okay.
And as they compacted and got colder, ultimately they would crack down the seams when the ice expanded.
Yeah.
Anyway.
Well, there you
Oh,
go.
the guy on the right's got a temperature sensor. You can just see it. he's playing with a temperature sensor. Yeah. We made those totally in-house.
Okay.
What else can you see there? Not much. What's the other guy got? He's got something that... I can't...
Tube of some description.
Yeah, not sure what that one is. Oh, yeah, it's wind.
Okay.
It's just a little anemometer on it.
Okay.
The wind direction was on the arm out the front. The
Yep.
pyranometer...
Sat on the top.
Yeah, I think it was on the top. We had solar panel also somewhere, and there was lots of discussion as to where the solar panel should go and what angle it was on. Ultimately, we just let it flat against the mast facing north.
Yep.
Let's face it, the sun didn't get much above the horizon anywhere. Even in winter and in summer, it didn't at all.
There you go.
Yeah, so the electronics was buried
Okay.
at a couple of metres under to try and
Stone
make it
lines.
not subject to the really cold temperatures, to the winter temperatures. So if you go down a few metres, you get an average between summer and winter temperature, which is,
Okay.
summer is still cold, but down a bit is less severe than the winter temperature.
Yeah. Okay.
So,
Okay. Okay.
yeah,
Fantastic.
yeah.
Oh no, good stuff. Well, that is that's fantastic. I look forward. Oh, all right. Hang on. Hold that thought.
No, there's going to be I think that you can see the pyranometer on the top
You can.
and the anemometers at various heights.
So this is the
Pyranometer.
that one there. That's temperature.
No, I reckon that's the pyranometer.
Okay. These are wind
Yeah,
directions just there.
yeah. This might be because there's a temperature one right down the bottom. That could be a temperature one up there.
That down
That's
here.
temperature.
Yep.
You can see the solar panel
Oh, there.
there facing north. Oh, the bit hanging down on there, that's one of those Polaroid
Oh, okay.
ultrasonic
Yep. Looking at the snow.
Snow.
Okay.
No, I've forgotten. Yeah, temperature.
Oh,
That's
they
it.
flew in.
Yeah, that's a newer weather station. As I said, I can tell it's a square one. The earlier ones were round.
Oh, there you go. Out in the middle of nowhere, in a very harsh environment.
Yeah. And as I said, we basically never went back to them. They had to work from day one until they ultimately got buried.
Yep.
And even when they were buried, they'd still give temperature readings.
Yep.
Except
Okay.
we wouldn't necessarily know the depth.
Yep.
And they'd often give pressure readings
Okay.
because that would, the fern or the snow would allow air pressure through it.
Yep.
It's,
Yeah.
lets air through. So yeah.
Well, there you go.
Yeah. Anyway.
That is fantastic.
Shut me up when I keep going on too long about these things.
No, this is absolutely fantastic, and the information about the sensor was certainly available. I did end up finding it.
Yeah, you told me.
And it is those. It is the right one.
It is the right one because the number on this side
Yeah.
says 215A something or other,
Yeah.
and it says absolute pressure.
So, so certainly I'll be
Stability better than 1 hectopascal per year. Point 1
.1.
per year. And yeah.
Very impressive device, Al.
Yeah. So,
Very
as I said, I spent a lot of time making those component level, and the later ones were all surface mount.
Okay. And did you installing them actually down there? Were you involved
No,
with
I
that?
never installed one.
Okay.
Warren did,
Okay.
I think.
Well, you might be reinstalling them again.
No, I don't think we're making them now.
Oh, okay.
I think we've moved on to a different program.
And hello to Warren if he happens to catch this at some point on some feed or something.
On his 2 meg download via satellite, shared with currently close to 70 other people, I think.
Yeah, maybe not. Okay.
and all the admin on it, on the 2 meg download. Yeah.
Right, okay.
And he's just short of the Antarctic Circle at Casey.
There you go.
He's got to go inland a bit to go into real Antarctic.
We're looking forward to being told that he's on the air. So I think there's going to be an absolute scramble for contacts. I suspect when he says he's on the air.
Yeah.
So yeah. But anyway, fantastic. Thank you, Alan.
I'll run away.
I'm looking forward to making the circuitry for it and putting it in place.
The later versions had an RS-232 output rather than frequency.
I found the specs for them.
Yeah, so you could actually just hook them up to your computer and get the data straight out of them instead of having to convert frequency to pressure.
Yeah, okay. And it's got a neat little DB9 on the side of it.
Yeah.
So
correct.
just a little RS-232 interface.
Yeah, I think they came with a calibration chart.
Yes.
Which then told you what they were.
Correct. And I assume that would be a temperature to pressure chart. I assume is that?
I can't remember.
Oh, sorry, a frequency to pressure chart.
Frequency to pressure.
Frequency to pressure chart.
From memory.
Yeah.
I can't quite remember.
No, okay. But anyway, watch this space. Once I get the little circuit and working and everything, I'll bring it in and
if we're lucky, one day they'll get one and they'll throw it out, and our resident tip rat will find it and he'll bring the whole thing in.
Excellent. And we can put one up here.
Yeah, and then I'll just start crying. we used to erect them in the back paddock down at the division where they used to have solar panels.
Yep.
Which is they've now gone, and it's now a hard stand, and they park vehicles there. That used to be our test site.
Okay.
So,
okay. All right. Well, fantastic.
Did we have one? We might have had one up at Cape Grim also.
Okay.
We had something up at Cape Grim. I went up to retrieve it at one stage. But I don't think it was a full weather station.
Okay.
Might have just been some of the sensors.
Okay. Oh no, good stuff.
Okay.
Well, thank you very much, Alan.
I'll run away.
No, that's all right. That's
Carry
great.
on with your normal programming.
Normal programming resumed now. Thank you very much. So what we will do, I'll just bring this camera back up again, and we've got a few little things that we're going to do. Now, let's see whether we can't... Oh, that's not right. The focus on this is interesting. All right. Now, let's go to there. That's a bit better because it's slightly better camera on this one. As you can probably tell, the color on this camera is a little bit better. We can't quite compensate for that one. But anyway, so that was the absolute pressure sensor, which was absolutely phenomenal. Now, we last Wednesday night we had a Focus on Foundation license forum, and which was a bit of a focus on foundation and membership things to do with the club. Had some fantastic input from foundation licensees and also members who all put into the forum, which is on the Reast YouTube channel. And we had the output of that forum went to the Reast committee last night, and we had a bit of a talk about what came out of that. Now there were a whole bunch of stuff that came out of this, which included a few things, which will see us appoint a membership officer, who is their role will be to link everything together and make sure that members and new new to the hobby and all of that sort of thing get on the various registers and get on the mailing lists and all of that sort of thing. Definitely some things around improved and updated website, so that's a work in progress. That's good. A little bit about skills register, which is if you've got a particular interest or a particular skill
that you're prepared to share with others, new members or whatever, then we will come up with some way of being able to register that and then pass that on in a privacy sensitive way. There was a little bit about theory and practical sessions out here, actually out here to utilise the club station on a Wednesday night. So we'll be running regular things on the club station, and also that'll on alternative nights what we might do is do a little bit of theory around the foundation, standard and advanced. So there'll be some things that we'll focus on. There'll be a schedule of sort of theories that we'll be focusing on that we'll publish. The welcome email and mailing list and the membership, the new members barbecue and meetings certainly will be happening. A bit of a buddy system. So this is about mentoring and Elmers and buddying up particular members with the similar interests and that sort of thing. Badges. You'll notice I'm wearing my badge tonight. So we'll be organising badges. So that people know people's names and be able to seek out people maybe that they've spoken to on the air or something like that, but maybe not know them in person. The club station, I mentioned just earlier, the club station we're looking to actually be utilised for as many contests as we can. So we'll invite people to come up and participate in the contest and experience the contest and find out what contesting is all about. 2 metre foundation licence net. So we're starting one of those. You'll hear a little bit about that in the not too distant future. Both voice, but also we were thinking about slow scan television and digital modes and all sorts of things. So on 2 metres. And having a few of the experienced members also on that, so they can answer questions that come up. Broadcast. Okay, on the broadcast, foundation members or new members who would like to call in, we give you a bit of a space to call in. So specifically give a little bit of space for those new members and new foundation members to call in. So and also shack visits. That's another thing that came up. So to see how experienced amateurs and other amateurs setting up their shacks and all of that sort of thing. So that's some of the things that came out of the committee meeting last night. We will be certainly implementing quite a few of these things. But that's a bit of a hint as to what's ahead. So yeah, and a huge thank you to those people who came along to the foundation night, as well as those people who sent in emails who couldn't make it to the night but did send in emails with some comments and suggestions around what they thought could improve the membership and improve for a foundation license and also new members. So there you go. So to finish off tonight, what I thought I'd do is just give you a bit of a sneak preview of the Old Timers News. Now, the Journal of the Radio Amateurs Old Timers Club of Australia. This is a very well put together journal that comes out regularly to the RAOTC members. The RAOTC broadcast occurred Monday night? Or was it Tuesday? No, it's Monday night. Monday night on the VK7RTC and VK7RAA in the north. And that broadcast comes out and takes callbacks at the end as well. So this is the I was just going to do a quick scan through of we'll zoom out a little bit here. So the front cover is a very nice multi-band beam. There's a bit of housekeeping and bits and pieces. The Old Timers News Stewart Day Award for 2021 was won by the Morse key collecting Herman Williamson, who is a VK2IXV, wins for the third time. So Herman's doing okay there. Loran, so the timing, it's rise, demise and rebirth. Some of the early Loran A receivers, various ships and the E-Loran arrangement versus the GPS type arrangement. A nostalgic trip down memory lane. Now, by Bill Roper, who is the editor of this fine magazine. A trip down memory lane of a whole lot of older type transceivers. I notice in here he doesn't have an FL50 and an FR50, which I do actually have from my old man. I do have a FT7 as well, which is a portable QRP rig by Yaesu. Very nice, nice. Kenwood's Yaesu FC7B with the extended frequency range. He's a linear. A Drake receiver, and then over the page, a little bit older rigs, a little bit more modern rigs, circa about 1980, I reckon. TS120, the Yaesu FT301D, and the ICOM IC701. So there you go. Now,
I've got a 551 and a 701.
Now I need to talk to you, Kim, too. So don't disappear. Now, this jumped out at me when I opened it up. Some receiving antennas for 7 megs. Now, this is by Richard Rogers, VK7RO. So, Hobart Coast radio station, the very one that we are transmitting from tonight, opened in 1912 and closed in 1992, and it shows VIH in the 1970s and the big biconical monopole that used to be up here, which ended up being removed and shipped to Melbourne, to Victoria, and being set up over there. And there was a few ideas of the vertical pattern of the 7 meg beverage antenna in this article, and the receiving loop for 7 megs. So thank you, Richard. A great contribution. Paul Edwards, VK7ZAS, a shocking discovery of electric fish, the 250th anniversary, and here's Benjamin Franklin here, and an article about the electric fish and the discovery of electricity way back in 250 years ago. Now, the ordinary telegraph is a very long cat. By again Herman Williamson, the original Morse key that used by Samuel Morse in the 1844 demonstrations. Iota, Pota, Sota and HEMA. What is it all about? By Ron Cook, VK3AFW. So a good little article about Sota, Pota and other things. The Bendix MN26C radio by Bill Roper. Compass radio, Bendix radio. Try the Other Foot by Herman Williamson. QLF is the code. Try your left foot. The Hedgehog Transformer, and this again is by Richard Rogers, VK7RO. So Hedgehog Transformers, and you can see a whole lot here on this this early amateur radio station, and then the making of the Hedgehog Transformer. The membership list, which is always in the middle. The Hill That Trumped a Mountain by Ron Cook, VK3AFW. Declassified Military Secrets by Bill Roper. Interesting little article about declassified... there's Douglas MacArthur. The Radio Australia, Shepparton, a short story. This is part 1 and 2 by Rodney Champness, VK3UG. So this is the Radio Australia transmitting station at Shepparton. And this also includes... here's Bill Davidson demonstrating a hotspot with a fluorescent tube that's not connected to anything but it's glowing. That was a trick. I remember visiting Mount Lofty television transmitters in Adelaide, and the guy who was showing us around brought out this fluorescent tube which started to glow with nothing connected to it. Quite interesting. Levinson Radio, the Palace of Wireless, and some articles. 2 cases of weak signal interference. Rodney Champness again. Louis Brennan, the inventor of the first practical guided torpedo by Bill Roper. So interesting article there. They watched and warned. This is the Coast Watcher stations that were around Australia and the Pacific, listening for radio traffic. Now, Andrew Walton, VK7KAJ, with an interesting article on cybersecurity, why you should take it seriously. And given I live, eat and breathe cybersecurity right at the moment as one of our biggest risks, it's well and truly be an article worth reading. So that's the Old Timers News. Really well produced little magazine that comes out about every 2 months, and really well put together articles from a whole range of people. So yeah, worth a bit of a look, and you can become an associate member if you're licensed for less than 25 years, or if you're licensed over 25 years, you can become a full member, and you can even become a life member if you want to pay the money. So OTN News, the journal of the Radio Amateurs Old Timers Club of Australia. So worth a look. Now, very quickly, we have some reminders, which is our April presentation night will be a great night, presented by Andrew Johns, VK7AJ, on a day in the life of a broadcast audio technician. Now, Andrew travels all over Australia to the biggest sporting events that occur in Australia, and he does the audio for these events. So absolutely fascinating. He's got lots of stories, and even more poignant stories now that one Mr. Shane Warne is no longer with us. So I'm sure there'll be some stories and some pictures, accompanying pictures of the absolutely phenomenal technology, 4K technology in a variety of semi-trailers that goes round to these sporting events. It is absolutely phenomenal. So be a fantastic night. And the other thing, the WIA virtual AGM and conference has been announced and is out there for people to book. The virtual conference is a theme of Antarctic Gateway, and it's occurring. It's actually emanating. It's a virtual conference, so most of it is all online, and you can view it online. But there is. It's emanating from the IMAS Lecture Theatre, Aurora Lecture Theatre down here in Hobart. And so locals are very welcome to come along in person, and I think the presenters would probably appreciate having an audience. So it's been announced. Everything's on the WIO website, so you can have a look there. You can also register for the event there through the Everbright registering ticketing system. So there you go. That's our show for tonight. Thanks for watching, and there'll be another important show next week. And next week we'll actually have, hopefully we'll have Larry in the studio with his Belka DX SDR. So this is a fascinating little box that's about yay big, which is a full SDR. Actually, sorry, I can take this off now because I'm the only one in the studio. So there's a beautiful little Belka DX SDR receiver. Very, very small, and does a phenomenal amount. So that'll be one of our things featured next week. So from Larry, VK7WLH. So anyway, we'll bid you 73, and we'll catch you next week. We've got a whole range of videos for our RF viewers from Vertasium, and one that came from Ollie, VK7NFI on numbers stations, and jammers and war propaganda on shortwave happening now. So some Vertasium, some Tom Scott, and some M0SZT videos for our RF viewers. So we'll get underway with those shortly. Anyway, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And we'll catch you next week, 7:30, next Wednesday night. 73.